Welcome class 6. Today we are going to start with chapter 25, properties of angles and lines. So the first property that we are going to discuss is when two lines intersect. So when two lines, let's say line AB and CD, intersect at point O, then the first thing that we'll notice over here is the sum of each pair of adjacent angles is always 180 degree. Okay, we know that what is adjacent angles. So over here, let's say that angle AOD, this angle over here, this is adjacent with angle DOB. Okay, this angle DOB and this angle AOD are adjacent angles. Okay, so if you take this angle AOD, this angle and angle BOD, and if you take the sum of these two angles, okay, this angle and this angle, then it will be equal to 180 degree. Why it will be equal to 180 degree? Because angle AOB, since AB is a straight line, so angle AOB is a straight angle which is equal to 180 degree. So that means this angle AOB from here to here, this angle is 180 degree, and this 180 degree is divided amongst AOD, one of the angle, and its adjacent angle is angle BOD. So any pair of angles, for example, if you take AOD and AOC, this again both the angles if you add will be equal to 180 degree. If you take angle AOC, this angle, and angle COB, in these two angles also if you take the sum, it will be equal to 180 degree. Similarly, if you take BOC, this angle, and angle BOD, again the sum will be equal to 180 degree. So that is when two lines intersect, this will be the first thing that you will notice. Number 2 is the vertically opposite angles are always equal. Vertically opposite angles means, let's say this angle, angle AOC, this angle, angle AOC, and the opposite angle to this one is this one, okay, this angle, that is angle DOB. So angle DOB and angle AOC are vertically opposite angles and they are supposed to be equal. So AOC will be equal to DOB. If this is 60, this is also 60. If this is 100, this is also 100. Okay, their values will be equal. Similarly, angle AOD, this angle AOD, and this angle BOC will also be vertically opposite, and vertically opposite angles are always equal. Okay, so that is property number 1. Next property we have for the straight line is if the sum of two adjacent angles is 180 degree, their exterior arms are always in the same straight line. For example, see over here, the two straight lines are intersecting. Okay, line AB and line CD are intersecting at point O. So if the sum of two adjacent angles is 180 degrees, suppose if these two adjacent angles, angle AOC and angle BOC, like in previous case, if they are added and if the sum becomes equal to 180 degree, this means the two exterior arms, in this case this arm AO and arm BO, will be the same straight line. So over here it's a same straight line, isn't it? AO and BO are the same straight line because they are, they are straight lines and they are forming the angle of 180 degree. So this can be said in the other way also. It can be said as if the exterior arms of two adjacent angles, so if these two are the angles, adjacent angles, and these AO and BO are again the two exterior arms of these adjacent angles, and if they are in the same straight line, then the sum of the angles is always equal to 180 degree. Okay, then this angle plus this angle will always be 180 degree. So it's just like saying the first thing in this way and saying the same thing in a different way. Okay, just the other way around. Okay, so if the sum of two adjacent angles is 180, then their exterior arms are always in the same straight line. And this one, if the exterior arms of two adjacent angles are in the same straight line, then the sum of angles is always equal to 180 degree. So these are the two properties that we are going to follow in exercise 25A. So let's look at the first question. Question number 1. Two straight lines AB and CD intersect each other at a point O and angle AOC is equal to 50 degree. So let's have a look at the figure as well. So these two are the two straight lines intersecting. AB and CD are intersecting at point O, and angle AOC, this angle is 50 degree. So you have to find angle BOD, this angle BOD, angle AOD is this angle, okay, and thirdly you have to find angle BOC, this angle. All right, so let's look at the solution. Now angle AOC, this angle, and angle BOD are vertically opposite angles, okay. So we can say angle BOD and angle AOC are equal because they are vertically opposite angles. So this means that angle BOD will be equal to the value of angle AOC. So angle BOD will be equal to 50 degree. So this is the first answer. Angle BOD equals to 50 degree. Number 2, you have to find angle AOD. So we know that angle AOD, this angle AOD, this angle, and this BOD, this and this angle, they are adjacent angles, and they are supposed to be 180 degrees. The sum will be equal to 180 degrees. So angle AOD plus angle BOD is equal to angle AOB, this angle, okay. What is angle AOB? It's 180 degree. So put the value. AOD is AOD, angle BOD just now we have formed it as 50 degree, okay, and angle AOB is equal to 180 degree, okay, this angle. Now simplifying this, let's bring this 50 this side towards right, so we will get angle AOD is equal to 180 minus 50, and simplifying this you will get angle AOD is equal to 130 degree. All right, so this is answer number 2. Next is you have to find angle BOC. So number 3, angle BOC is equal to angle AOD. See over here, angle BOC, this angle and this angle AOD are vertically opposite angles, okay. So they are vertically opposite angles. So what is angle AOD? Just now we have formed it. It is equal to 130 degrees. So angle BOC will also be equal to 130 degree, and that's the third answer. All right. So similarly, we'll do question number 2. Let's read the question. The adjoining figure shows two straight lines AB and CD intersecting at point P. So let's look at the figure. Over here, AB and CD are intersecting at point P, okay. So if angle BPC, this angle BPC means this angle is equal to 4x minus 5 degree, and angle APD is 3x plus 15. You have to find the value of x, then you have to find angle APD. Also you have to find angle BPD, and you have to find angle BPC. So let's look at the solution. Over here, angle APD and angle BPC, they are equal because they are vertically opposite angles. So let's put the value. APD is 3x plus 15 and BPC is 4x minus 5. So let's put the values. 3x plus 15 is equal to 4x minus 5. Bringing this 4x towards left, you will get 3x minus 4x, and bringing this 15 towards right, you will get minus 5 minus 15 degrees. Okay, simplifying this, we will get minus x is equal to minus 20. This means x is equal to 20 degree. So the value of x, number 1, is you have to we got the value of x is equal to 20 degree. Next, you have to find angle APD. Angle APD means this one, okay. So 3x plus 15 is the value, and just now we have got the value of x to be as 20 degree. So angle APD is equal to 3x plus 15. Putting in the value of x, you will get 3 into 20 plus 15. Bodmasses will multiply first. So 3 into 20 gives us 60 plus 15. 60 plus 15 is equal to 75 degree. So angle APD, this measurement is 75 degree. So this is answer for number 2. Next we move on. We have to find angle BPT. Okay, angle BPT plus angle APD is equal to angle APB. So have a look. BPT means this angle plus angle APD. Okay, they are, there are two adjacent angles, so they'll be equal to straight angle APB. Okay, let's put the value. APD is 75 degrees. Just now we have got in answer number 2, and APB is a straight line, so it will be equal to 180 degrees. Okay, now BPD is equal to 180 minus 75. Simplifying this, you will get BPT is equal to 105. So this is answer for number 3. Next we have number 4. Angle BPC is equal to angle APD. Both the angles are vertically opposite. So BPC and APD are vertically opposite. So the value of BPC is equal to 75 degree. Okay, so this is the 4th answer. So with this we come to an end. Okay, the assignment is exercise 25A, page number 226, question number 3, 4 and 5. All right, thank you.